All right, let's get to exercise number 2. Let's see what it asks us to do. Cubes that follow a curve, it's named. So, draw a curve in Rhino. Find points on the curve, distance at 3.2 units between them. Generate cubes centered on the aforementioned points. And orient the cubes to follow the curve, meaning they have 4 edges parallel to the tangent to the curve where their centers are. So each cube has a center on the curve. In that point, there is a tangent on the curve, and the cubes need to have 4 edges parallel to that. It sounds complicated, but it just means that the cubes are always oriented in order to follow the curvature of the curve. So let's start. Draw a curve in Rhino. This is simple, just get this and make a few clicks and presto, you have a curve in Rhino. Then we need to get points on this curve that are distance at 3.2 units, right? Find points on the curve distance at 3.2 units between them. All right. In order to do this, we will look at curve at division. This is where you find ways to get equally distance points on a curve. And the component that we need is divide distance, because this component basically has as a parameter the distance between consecutive points. So divide distance, boom. And we need the distance, which is 3.2, so just double click anywhere on the canvas, write 3.2 and enter, and you will get a slider with that value, bam. And then we need to tell the component which curve to actually divide. Although it's not properly a division, it just takes points on it, but anyway. You can right click it and set one curve and select the curve, or I would suggest to use one of these components, either curve or general geometry. Right click, set one geometry, select the curve, and now we have here that curve, and input it in here because you might need it somewhere else along the way. Okay, so we have a few points on the curve that are distance at 3.2. Now we want to make cubes on these points. In order to make cubes, you want to write cube because you won't get any valuable components. This one cube just takes a value at the power of 3. You will write box, which is a parallelepiped, and you will get this one, center box, because we want the cubes to be centered on those points. So center box, and we can use the points as base, and we will get these cubes. But these cubes aren't oriented the right way. Where it says base, it actually means base plane, as you can see. And if we input points, these points in here, it will get basically it will make some horizontal planes that have their origin in these points and have their axis oriented the same as the world axis. But that is not what we need. But it's an easy way to make this orient to follow the curve. And to do that, we need to look at other ways to define planes. So let's go to vector, and here in plane, you will see the plane normal. Plane normal defines a plane all right. Plane normal defines a plane by its origin, which is going to be these points along the curve, and a z-axis, which means the orientation of its vertical axis, because each of these planes has 3 axes, x, y, and also but also z, or all x and all y and all z, all being the origin. And for the z-axis, we will use the tangents. And now you can see how these planes look. If the planes are too large or too small, you can change their size by going to display, preview plane size, and just write another number in here. So the planes seem to follow the curve, right? If you use these planes as basis for the cubes, we will get cubes that follow that curve. But remember that these cubes basically sit on a side, because the z value here is the tangent, basically. So let's write 1.2. So if we modify the height of the cubes, the height is along the axis of the curve. So you need to keep this in mind. And that is it.